All right. How's it going, Dexter? Let me see. What'd you say you're running today? ESP32 and a AT-Tiny 817. You know, I've seen a couple of folks mention that AT-Tiny 817 recently. I don't know too much about it though. Is that just a new version of the Seesaw, basically, or? Oh yeah, there we go. Okay, yeah, it looks like it's just kind of a new version of that Seesaw, right? This is the original. Well, I don't know if it's the original. It's the one I'm familiar with, though. Seesaw. And that was a SAMD09. It's bumped up to an AT-Tiny 817, and it has a stemma port on it, which is pretty nice. Same price point. Cool. Yeah, that's really nice to have the stemma port on there. I haven't messed with the Seesaw too much. I picked up one at one point because I was going to use it for testing something, and I didn't end up needing it. Yeah, somebody else tested it, or I don't remember exactly what happened, but one reason or another, I never really busted it out to use it. I do know a couple of the boards have built-in Seesaws though, like the what is it? Not Halloween. The Two Eyes one. Oh man, I'm drawing a blank. Oh, Monster Mask. That's what it is. The Monster Mask has a Seesaw just built onto the board because it has so many extra peripherals and stuff. So I learned a little bit about it when I made the library for that Monster Mask. It seems like a pretty neat little utility device, though, right? It's like kind of a Swiss Army knife of breakout boards, basically, of like GPIOs. You can add extra, just plain like digital input outputs. You can add analog input outputs. This one's got the stemma ports, so it can connect up to I2C devices. I assume it probably has SPI also. It's kind of like a real neat catch-all expander chip to add more pins to your project, basically. Got a 8 LED NeoPixel stick. Nice. That sounds like a fun project for the day for sure. All right, so let's do a quick introduction. Let me actually shuffle around a few more of these windows real quick. I don't think I need this preview. We could minimize that. All right, that should be good. So hello, everyone. My name is Tim. I go by foamyguy on GitHub and Discord. And in this stream, we're going to be working with CircuitPython, which is the things normally that I stream about are CircuitPython related. If you have never caught the stream before, if you're brand new or you're watching the video after the fact and you don't know what CircuitPython is, you can learn more about it on this website right here, circuitpython.org. But to give you a quick high-level introduction, it's basically a version of Python that can run on these tiny computers called microcontrollers. There's one built into the lightsaber right here. There's also pictures of a bunch of other ones in the background on this page. So this is a version of Python that runs on these tiny little devices and allows you to interact with other hardware peripherals like buttons and lights and sensors and motors and pretty much any kind of little electrical doodad that you can imagine. CircuitPython will allow you to write programs for these devices to interact with it. In this stream in particular, I tend to do a lot of work with display I/O related stuff. There are days, there are weeks where I mess with other more electrical type things. We were working on a LED matrix for a couple of streams, a few streams back, so that one didn't involve any display I/O. But a lot of times I am drawn kind of to work in display I/O land. So a lot of times I'll be working on a device like this one back here, which is a Pi Portal. It has a built-in screen, or maybe a Pi Gamer, which is this one down here, or a Pi Badge like this one here, which has a built-in screen. All of those support display I/O natively on their built-in screen. So that tends to be what I work on a lot, but it's not like 100% exclusive. It just kind of depends on what I feel like that day. Today, what we will be working on is this Raspberry Pi Pico with the WaveShare 1.14 inch LED screen. So if you caught last week's stream, I was working on a library to basically be like a driver or a helper library for this particular screen. It's plugged into a Raspberry Pi Pico. You can't really see it underneath there too well. I could turn it over. You could see the back of it there. This is just a little device by WaveShare that plugs on top of the Pico and has this little built-in screen. You know, again, getting into the display I/O world. It's got this built-in screen. It has a D-pad right there, so it's got up, down, left, right, and then, you know, center. You can push it straight in to get center. And then it also has 2 buttons over here on the side. So last week we made a driver, like, helper library for this. We ran into a strange issue in the core, and we took a little bit of a, rabbit hole. That's not really the word I'm looking for. Detour. We took a little bit of a detour into the core to fix that issue that we found when we were working on the library. And that is pretty much where we left it last week. We had the library working. It initializes the display. All the buttons work. And then we went inside the core and fixed that issue that I ran across when I was working on the library helper. So that's where we left off. Today we're going to be picking up this same device, but what I'm going to be working on is not a library or a helper driver or anything like that, but instead I'm going to be working on an actual end project with this. So we're going to try to make a sort of Pacman type game clone. So it probably will not end up being 100% the exact same as Pacman. Of course, the screen is a different aspect ratio, so we wouldn't be able to see all the same stuff. We'll have to either play with really, really small maps that fit on this screen, or else we could implement some camera logic that will allow the camera to move around the screen to different parts of the map. I have some assets ready to go that I made for this right back here. So I made a couple of these, pretty basic little a sprite sheet with a couple of sprites that we can use. Basically, we have, the character is the little yellow pie chart there. He's got an eyeball, and then I've got one for each direction, and then I've also got another one for each direction with the mouth closed. So the idea is we're going to have him, doing the whole chomp thing with his mouth opening and closing. I got a ghost, a couple blue lines for the walls, and then of course the main, goal of Pacman is to eat the little dots that are around the map. So we got a little dot to eat as well. So we will be working on some of the tile map library stuff that I have done a few times on stream. We'll be loading that up with these tiles and then implementing the logic to make your little pie chart move around and chomp the little dots and run away from the ghosts and all that stuff. Before I do dive straight in, though, let me also go back and just talk about real quick, again, CircuitPython. If you're interested in the project and you want to help out, you want to get involved, you can go to circuitpython.org, and then you can click on this contributing link up at the top here. This is going to take you to a list of all of the open pull requests and all of the open issues. And inside of issues, if you're brand new to this, there is a drop down right here for sorting by issues. You can sort by good first issue. And these are all issues that have been selected because they are relatively easy as far as contributions go. The vast majority of them right now are these missing type annotations. So that's just all about adding the type annotations into the functions inside of all these libraries. And so that's a great place to start because it's not, you just have to figure out what type it is and then make the declaration of it there in the function signature. There's not a whole lot of, actual, I guess, logic to do. There's not a whole lot of, opportunity for too much to go wrong. So it's a good place to start for folks that are brand new and want to get involved. Another way, though, that you can help contribute to the project if you don't want to actually get involved in the development is you can purchase hardware from this company right here, Adafruit.com. These are the folks that are the primary financial backers behind the CircuitPython project. So they pay Scott and Jeff and Katney and Dan which are the full-time CircuitPython team, the developers. So they pay those folks to work on CircuitPython full-time and to foster the community around the project and do all sorts of other things around the project. So if you, again, don't want to contribute development, oh, that's kind of cool. Got like a muscle reader going on there. Sorry, I'm a little easily distracted sometimes. That is interesting. What is that? Muscle sensors? Okay, so let's finish up and then I'll look into this. As I was mentioning, they pay the folks that work on the project. So if you purchase hardware from them, which you can do on their website, adafruit.com, then you are, indirectly helping support the project, of course, since they provide the money for it. Okay, so this is interesting. MioWare muscle sensor, interesting. I had no idea this thing existed. All sorts of interesting stuff you could do with this. So yeah, on their website, they sell the microcontrollers. They sell, all the different sensors and LED lights and all the things that you can plug into the microcontrollers, including some really interesting stuff like this one here, which is a, an EMG, electrical pulse sensor. So you can, stick it onto your arm or your leg or somewhere, and it can sense when you flex your muscles. Just kind of a crazy thing to think about, but. So yeah, that's Adafruit. That's another thing you can do to help support the project. They do pay me sometimes to work on guides and other software, so I do work for them sometimes. But this stream that we're doing right here, this is not a paid stream or anything. They're not paying me to promote their products or mention it at the top here. I just always like to do it because, of course, I really like the project and want to help it in any way that I can. So I figure, giving a quick shout out at the top is one of the easiest ways I can help. So. Now we can dive into what we want to work on, which is going to be Pacman. I think real quick, actually, I'm going to open a window. It's a pretty nice day out, so I'm going to open a window just to get some air moving and cool it down a little bit here, and then I'll be right back. All right, see how that goes in a few minutes here. I might pop the fan on or maybe open the other window as well. We'll see what it's like in a minute or two. So I am not entirely starting from scratch. I do have the sprite sheet created here. We might add some more stuff to this, right? Like we only have one ghost, whereas the real game has got, I think, 3 or 4 different colors of ghosts. Plus there's also the ghosts when they become edible or whatever, right? Like you chomp the fruit and then the ghosts, they start blinking a different color. And then Pacman is allowed to eat them. And so we don't have the sprite for that secondary color. And we don't have a lot of that stuff. Hey there, H-Linge or Highlinge? I'm not 100% sure how to pronounce your name. In the Twitch, I'm in the United States. I'm in Kansas City, essentially. So yeah, like I said, we're missing some of the stuff here. We don't have 100% of everything, but we have enough to get started. Okay, one more thing here. I'm gonna need to move this real quick. Okay, back at it. So this time of the year, the sun likes to come right inside these little windows by the door here and reflect right into my eyes. Here in Denmark, it's getting cold. Oh, cool. Yeah, that's pretty cool. Yeah, it's just started cooling down, like within the last maybe 2 or 3 weeks or so. We started getting cool enough to not use the AC very much and start opening up the windows. We'll have probably like maybe a month or a month and a half or so where we can have the windows open pretty much every day, but then it'll probably be getting too cold after that. Once the winter starts up for us, what we got here. Let's just disconnected. These things like to hop on and off real quick. I'm gonna hit the reset here and see if that will jog them. If not, I'll just keep going. It's not really that important. There we go. Okay, we don't want to switch. Let's take that away. All right. So yeah, we don't have 100% of everything for the whole game, but we have enough to get started with. Another thing I want to do is open up tiled. This is the map editor. Pull it here for 1 second. We're going to close off some of these things to get ready here. Some of these are the older stuff that I worked on, like, let's consider maybe later. Maybe later. I probably would donate to them. This is a pretty cool program. So these are some of the maps we worked on before in different projects. Pacman, like this one, is one that I've made with the actual Pacman tiles. I think what I'm going to do to start with is I'm going to make one that is the same size as the screen that I'm working on. So my screen is it's 135 by was it 240 or something like that? Let me open the library. This will have the size in it in the initialization. So we are going to use that library that I worked on last week. Yeah, 240 by 135, and my tiles are 15 by 15, so 15 pixels by 15 pixels, which turned out to be kind of interesting. In the tile map game helper library that I've made previously, there was a lot of stuff hard-coded to 16, tile widths that were 16 by 16, because that divided evenly on the Pi Gamer and the Pi Badge and some of the other devices that I use. So we will need to tweak the tile game library a little bit to not have hard-coded sizes. We'll need to either let that get declared when it's initialized, or maybe we can read it out of the tile map JSON file. I think those are stored in there, so I think that's what I'll try to do if we can. So we'll need to work on some of those changes today. I'm going to get a map going here, though, that will just be the same size as the screen to start with, and then we'll worry about making a bigger one later with the camera that's going to scroll around. So we have 240 by 135. I don't know off the top of my head, what is that? So 240 over 15 is going to be 16 by 135, 15, 9, 16 by 9. So we will say tile width is 15 by 15, map width is 16 by 9. There we go. Go save as. And I'll put this, I have a repo for Pacman, so I'll put it inside there. Pacman map 0, I'm just going to call it map 0, and we want to give it an XML because the tiled file is XML, the file that you can open up and edit with tiled, the game map editor, but then we'll export it as JSON, which is how we will then be able to import it into CircuitPython. So we want to load up the tile set. Let's go browse, repos. If I can search in here, Pacman, yeah. Spreadsheet, there it is. We have our transparent color is green, that's already selected. We have 0 margin and 0 spacing, which is correct. We'll name this actually, I guess we'll just leave it. I think that's the name of the file, so we'll just leave it. We want to embed it in the map. I don't remember what that does, honestly. I'll just leave it on, I guess. Yeah, I don't know if I don't remember what that does. So that's going to give us the tile map here. So one thing I need to do in this one is make a background layer. We're going to make a new tile layer. We're going to call this one background. And actually, I'm going to look in tile map helper because I think it tries to pull the layers. This is by index, actually. Maybe it doesn't care, actually. Background tiles. Grid. It doesn't look like, actually, that it is. Yeah, it doesn't look like that it's pulling the tiles by, the layers by their name, so you might not actually end up needing that. So it doesn't really matter what we name it. So I'll just go background and foreground, I guess. Background is basically going to be filled with black tiles so that we have darkness in the back. I think technically we could leave those transparent and maybe it would look the same when it ran on the CircuitPython device, but it really helps in the editor here to be able to see them. Hey there, T Miller 51, how's it going? What you working on today? Got anything fun going on? All right, so let's go and make let's make some walls around the outside, and then we'll just make like 1 or 2 things on the inside. So I'm also gonna pull up a picture of Pacman. I don't really remember how it works exactly. Not really. Nah, that's cool. That's cool too. It's good, you know, sometimes you gotta just hang out and not do a whole lot. I can definitely relate to that. Pacman. I guess actually they don't have walls. That's right. They have, well, they do have walls, but they also have, you can also like go off the edge, right? You can go off the left edge and then wind up over here on the right edge. They do just have some regular walls there around the outside. Okay, so I think I'll just, and they are double lined. So all the walls in Pacman are made by 2 lines. Mine is not going to look the exact same as this because I don't have special special double-lined ones. Mine will be more like this. All the walls will be the same size in between there. We'll just kind of do something a little bit like this. I'm going to... I don't want to fill anymore. I'm going to go like this. And I'm going to copy these. And stamp them here? No, how do I stamp them? Shape fill. Maybe shape fill? Yeah, there we go. No? There we go. Do the same thing down here. Can we make a corner here? We can go like this one. Oh, we want to go further in, don't we? Yeah, we want the corner to be here. There we go. Go. One of these. Will I post the code? Yeah, I'll post the code. Yeah, I'll have a repo for it. There's not a whole lot, you know, there's not really enough to share right at this moment. I can link you to the tile map game thing. That's already public. The library that actually helps read the tile maps. I can post that, and then yeah, once I'm done with the Pacman, or maybe not even done, just once I've got it good enough to do interesting stuff. Where's yeah, this is the one here. a link to that in the chat. So that's the library that reads the tile map game. There's a couple of, that's kind of just a repo that I dumped a bunch of stuff into. So it's got some different maps. I don't think it has anything for Pacman in there yet, but it does have some different maps and some instructions on how to set this stuff up to use with CircuitPython a little bit. It could certainly use more, but there is a start in there. And I would say if you find yourself playing with it and you are having trouble figuring out how to do something, you can you could hit me up here on Twitch if I'm here, but also on the Discord, the Adafruit Discord, which is the chat that's showing on the screen there. I'm there most of the week. I've got that Discord opened up, so I hang out there. You can usually be able to get a hold of me there, or there's also lots of other folks that work on CircuitPython that hang out in that Discord, so it's a good place to find folks if you ever need help with something. But I think what I'll do is just make another little thing in the center here. Actually, how big of a section do we have here? Let's just fill it all with dots. And then, yeah, let's just make one little cutout somewhere, like, maybe we'll make this. I don't know exactly how I want it to look. It doesn't really matter that much, truthfully, but. Okay, so that would be too tall, actually. And we need to go the other way. Let's put these back to Liveryman's here. Second. Okay. I may be getting up in just a minute to wrangle the cat so that we can grab the delivery. Yeah. Do that. I'll be right back. Okay, there we go. So I think I'll just make I'll make a horizontal one here. Just put it in the middle. Can't really go exactly in the middle, but it's close enough. Let's do something like that. There we go. Okay, and I need to put, yeah, I think I'll put, I'm not gonna worry about a ghost just yet. We'll build in the ghost afterwards. I'll put a Pacman though. I'll put one Pacman. We'll put him down there in the corner, and we'll make a we will make properties on these things. How do I do that? It's been a little minute. It's been a little bit. Let me see. I think actually this repo, does it have? Set properties in the tile on the tile set. Right click the tile set, name tab, do edit tile set. Edit tile set. Zoom in some here. Okay. Split editor, custom properties. So what do we do for those? Right click custom properties, add property. property. I probably want to select the thing that I want to add it to though, right? So let's do the walls. Custom property, add property, can walk. Boolean. So these are all no. We're not allowed to walk on these. So I'm going to leave it unchecked. I don't know if I specified. Doesn't look like it. I'm pretty sure that's what this library looks for. Yeah, can walk right there. Okay, so those are turned off. We're not allowed to walk on those. We are allowed to walk on the background, although the background is in its own whole layer, and there's really nothing but backgrounds. I don't know if it matters too much. I'll go ahead and add it. And walk true. We're allowed to walk on the ghost, but eventually, you know, the ghost will hurt you if you walk on him. So, but we definitely, you know, we don't want it to block you like a wall would. Can walk on these. True. Turn the check mark on. Okay, and we're only ever gonna have one Pacman for now, so we don't really need to put can walk on the Pacmans. Because you know, you are the Pacman, you'll never see another Pacman that you can or can't walk on, so we don't actually need to do it there. What I will do though is I will do all the Pacmans and I'll go add property player. Player is true. I think something inside of here looks for player. Yeah. Get tile property. Player. Yeah. And we'll need to modify this library some too, because this library was built with the idea of the player always being in the grid of the tile map. But in Pacman, it's going to be different. The player will be allowed to move like individual pixels, even though, you know, they're in between the grids of the tile. So we'll need to change up that concept a little bit. But I think we're good here. We can save this. We can head back to our map here, and we select something. I was thinking it should show us the custom properties. Doesn't seem like it is, though. I guess they show when we highlight here. Okay. Yeah, they do show when we highlight here, so that's fine. Okay. Yeah, that's probably good. So I'm going to save the map as well, and then I'm going to export it as a JSON. Export. JSON. Pacman. Pacman map 0. .json. Okay. So now we have Pacman max 0 here. We have the background layer, we have the foreground layer. And we have all of our properties for all the tiles, like whether they can walk or whether they are the player. Okay. So now let's work on just getting this rendered on the screen. So we will need the game helper. What have I changed in here? Contents are identical. Why is it green then? Or not green, but blue, I guess. Interesting. One difference. Oh, okay. Take that out, I guess. We don't need the new line. Okay, so I'm going to copy this. We're going to put this over in Pacman. project. And I'll just keep this same name. This is like the helper library, so we don't want to name it specific to this game. Let's see. We need to... Let me install image load so that this is... Actually, I could do it from here so that this won't be red anymore. And it will have a little bit of type information, maybe. Interpreter plus image load. Interesting. I don't know if it's going to succeed. Yeah, I guess it did. It usually take that long. Okay. So now we know what that module is. So, like I said, this has got a lot of things hard-coded for 16 by 16 tiles. And we're going to need to change that up. So I think what I want is, the way you initialize this is you pass it the map JSON file. I don't remember if you need to open the file first or game test 0. Group. Okay, this is not using the helper. Yeah, it's not using the helper. It's also not using the helper. Map object. There we go. Okay, you initialize it by giving it the JSON file, the one that we exported from tiled. And so I think in that file it should have the sizes. So let's see. Has a height, layers, tile height, and tile width. We can get those out of the map. So inside of init, we open the file, we load it into map object, and so we can read from there this. We should also, another thing that's hard-coded is the size of the tile grids, which match a different screen. This was for the screen with 16 by 16 tiles, and it was a 10 by 8 sized display. Ours is, of course, different. I don't think we want to read that out of the map, though. It does have the size in here, height 9, width 16, so we could read it out of here, but that's not really what we want. I think what we want is for it to match the exact same size of the screen, which in this case it happens to be what's in the map as well. But if we made our map bigger and we had our camera able to pan around the screen, then or pan around the map rather, then we would want this still to be the size of the screen, not the size of the map. So I think what we'll do is let's get the tile width and tile height. Map object, tile width, tile height also. Then let's divide to get the screen size. Oh, we don't have access to the display. I don't have access to the display. Maybe we should just accept. Maybe we should just accept extra parameters. Where do we want to pass the display? I think, let's just take extra parameters, I think. So this would be, do we want to call it just width and height? Camera width and height? I think I like camera width and height. Camera width. We'll default it, I guess we'll just default it to the old defaults that we used, which match the Pygamer. But of course ours is actually different. Camera height, 8 is what the old default was. Camera with camera height. Okay, so then we will, when we initialize the tile grids, we'll use those values. Camera width, camera height. We have our tile width and height now. Default tile, I guess we should accept that as well. Default tile, and I'll just put it on 15 like it was, but we will change it up for the Pacman game, unless it also happens to be 15, but that would be just a coincidence. Default tile. And we want to do this on all of these. Actually, tile grid. Do we need an entity tile grid this time? I guess. Yeah, I guess we will, because we would treat the dots as entities. And the walls too? The walls? I'm not sure. We definitely want this to be the full size of the camera, though. We'll do that. We'll do default tile. The player sprite, this one will be different. This one is going to be 1 by 1, which is the way it was before, and that's exactly what we want. These will be the tile height and the tile width, though. Default tile. We'll need to accept another one of these, I guess. So we probably shouldn't call this one default tile either. We should probably have like background default tile, entity default tile, player default tile. Let's rename this background. Let's go ahead and break these down to new lines. So then let's do entity default tile. Player default tile, and we'll need to we'll still need to make some changes here to figure out how to do the ghosts. Right now the ghosts would not work very well in this helper library because the entities currently are assumed that they're going to stay in the grid of the tile map. But our ghosts are going to have the same ability as our player. They're going to be able to move 1 pixel at a time, even though that's in between the grid of the tile map. So the ghosts are going to actually need 1x1 tile grids instead of, camera size tile grids. So once we get to working on the ghosts, we'll need to do that. Go ahead and swap this entity. Put player. Cursor, I'm not going to have a cursor in this game, but I guess we'll default tile. I don't know, we'll set that on 0 as well. Or I guess it's 17. On 17. It doesn't really matter. Somebody would have to pass in the number that matches their sprite sheet. We do have these: tile width, tile height, and cursor is also 1x1. Cursor is a lot like player and how our ghosts will be, which is 1x1. Although the cursor does snap to the grid, the cursor doesn't move in between the grid. But that's going to add all these tile grids, so that gets rid of most of our hard-coded size stuff, which is good. Load the tile grids, update the player location, update the cursor location. So I think we should have, like, use cursor, false. And then we only do this if it's true. If use cursor could also maybe say self.use cursor true. That way we can refer to it later. Okay, so loading the tile grids. Anything we need to change in here? Gonna find the player one. Non-player entity. Does not look like I need to have the entity property. Empty space. So we should also maybe have empty entity tile. It has 15 in the other game. And we're not inside a knit anymore, so we should actually save some of this stuff. Should basically do this for all of these. Okay. Oh. A duplicate. There it is. Okay. Empty entity tile. Okay, again, we'll have to play with player location. We're not going to be working in just units of 16. but I'm gonna leave it for now. And walk, yeah. Should be fine. Get tile, that should be fine. Get tile name. So we don't have names on our tiles right now. We do that, maybe we'll put names on them. I don't know if it matters that much, but let's go. These ones are all named property name is a string. Name Pacman. I don't know, maybe we'll want left, right, up, down, and mouth open, mouth closed. I don't know if we'll need all of that, but right now I'm just going to put Pacman on all of them. All of these are walls. Name, wall. This is ghost. This is... I don't know what these are. Dot? I don't know what these are called. What does Pacman actually eat? Dot. What does Pacman eat? Pellets. Pellets. Ooh, we'll call this pellet then. Or not a spell pellet. LLET. Okay, got it right. Okay. So let's save our sprite sheet. Then we'll need to, we can save the map and we'll need to re-export JSON so that all that stuff gets updated into our JSON file. Yeah. Okay. Okay, so let's make a simple CodePy and try to load the map onto the display. I think we have all the stuff we would need now to actually be able to display it. So let's go into CodePy. I'm gonna take the starting point from here. And I don't think we need UGame in this case, or microgame, I think it is. That was being used for buttons. And we're gonna have different way to access the buttons. We will use our WaveShare library that we made last week. I'm actually just gonna copy this over into this repo as well for now. Eventually we would put this like in, you know, lib, and we don't need a copy of it in the Pacman repo, but just for ease of getting everything here in my editor, I'm gonna go ahead and do that. And get the simple test from this as well. I guess I don't need all of it. Let me, yeah, I don't need all of it. Let me just take this parts we need. So initialize the library, pick the display context, change size if you want. This is not needed. Probably already have a group. We could initialize the LCD right here. Display is actually LCD display. Already making a main group. We don't need max size anymore. That was taken out of CircuitPython, so we don't have to declare it. Don't have to worry about it. tiled map game, we give it the name of our file, Pacman map0.json. Okay, append the game. And this is all buttons. So I'm going to take out the button stuff for right now. Whoops. And we'll eventually put it back. But for right now, we don't need it. Pass. We just want to try to draw it. Don't need that. New lock. Moved false. I think we can leave those. I don't think they do anything. Okay, if everything works, this should render our map onto the display. So 2 things we'll need is the wave share and the tiled game helper. Copy those. We're going to put them on our device, which I have loaded up in this other PyCharm. I'm going to go ahead and get TO open for the terminal. We'll put both of those into lib. Actually, it looks like I have wave share already. Let me just put tile game map. I'm gonna put it into lib. And then CodePy is the simple test, which is already in the wave share repo, so we don't need this. I'm gonna take this, paste it, and then moment of truth, we'll put the camera over there. Save. Okay, no module named image load. Let's install that. Circup install. Okay, what's our next error? We didn't copy the map, of course. So let's get this back. And map0.json. Sprite sheet also, of course. We probably should have called it Pacman sprite sheet or something more specific, but that's all right. Ah, okay, we're pretty close. Didn't draw the whole thing. So what could be causing that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got only the first 10 columns. We're also missing the corner in 0, 0. And we're missing the entire wall on the bottom. Do we have 10 by 8? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we need to pass some of those new variables. Right here, we need to pass variables. Yeah. Oh, no, we should have got those. Oh yeah. We got the tile size out of the map, but we need to pass like camera size. Camera. I don't know why it didn't autofill that. Didn't I call that camera width? Yeah. I guess it doesn't. Well, doesn't know where this is at because of lib. I'm surprised it's not red, honestly. I don't know. Camera width, anyway, it's 16. This is in tiles. Is it in tiles? I think it's in tiles. Camera height is 9. I don't know if that's loud, if that's coming through or not, but neighbor's revving up the motorcycle, so if that is loud, then just bear with me for a minute. So now we have the right size, but everything... The top left corner is still missing, and every tile that's outside of 10 by 8 got filled in with the top left corner tile. Something is still wrong with the size, I think. These default tiles are probably what's causing all of these to get filled in. Which is okay for now. Past our new camera width and height. Size of our tile grid is correct. Let's look inside load tiles. Yeah, we have width and height here. Okay, so this needs to get passed. Width equals camera, height equals camera. Now we're looking better. Okay, so it loaded the whole map except for the 0, 0 tile. 0, 0 is still missing. It feels like our Pacman is a little bit too low as well. The pellet is not aligned with the Pacman's mouth, which isn't the end of the world, but in this it does look like it's aligned, so I'm guessing we have something. In fact, actually, it's going to be those 16s, right? We had 16, yeah. These can't be hard-coded. These need to be tile width and tile height, which we should save on self. Self. Okay, here we go. Self. Self. Red? Oh, yeah, all of these. Okay. Okay. 16. So this is going to be self dot tile width. This one's going to be self dot tile height. Same thing here. A height, a width. No more 16s. That's probably good. Save that. There we go. Now the Pacman's mouth is in line with the pellet, so he can eat it better. So what's up with 0, 0? We definitely have a corner there. What's up with 0, 0? Let's look in here. So this would be, it would not be in the background. Not going to be in here. It would be in the entities. Because that's where the layer with the walls is at. So, what is... It's to load. Okay, so this is where we get past our width and height, which we did pass in now. Is there more than one place this is called? There is. Set camera lock. We haven't, I don't think we called this, did we? Right now we just initialize no usage. Okay, so we will need to fix this, but that's not our issue right now. Y in the range of height, X in the range of width, extra offset, append, layer index data, tiles to load. So what's the first tile? The second layer, 16. Tile is that? 15, which I think we're +1, right? Because it says the ID 0. I think it's 1 based, if I recall correctly. Like, I think if we look in this list, we'll have a 1, but not a 0. Yeah. So 16, that seems correct. That is our top left corner. So the actual data in our map is fine. That's so weird. So, guess let's just print some of this stuff out. Print building tile list for format layer index. The range, these will be starting on 0. So the first time through the loop, appObject.width, that is 16 minus width, which is also 16 in this case. No, yeah. Is that right? Yeah, camera width, which is 16. 16 minus 16 is 0. 0 times 0 is also, so this should be 0 the first time through. Files to load, append, get the layer index, get the data from it. X should be 0 as well, plus Y, which is 0, times, well, okay, so I guess Y times width would go first. 0 times 16 should be 0, plus 0 is still 0. Start index. Start index. Zero times 16 plus 0. Okay, well, I guess let's print these things out. Okay. So extra offset is 0, start index is 0, building tile for list, so this is layers, basically, like background and then foreground, so the background layer was 0, the foreground layer was 1. Seems like we should be okay, honestly, with that stuff. Print tiles to load. Okay. So we have a 16 here. This is definitely not drawn. Okay. The entity tiles equals build tile list 1. Let's print it here. I mean, it should be the same. I think, right? Print entity tiles. Be the same. Okay, it is. 16 is our first tile. Index and tile index in enumerate entity tiles. Print XY format XY. So it should be 0, 0. That's a lot. First one of these should be 0, 0, which it is. Tile index is not equal to 0. Tile index. Hopefully it's not just like the display is bad or something. I don't know. Just, I mean, it's drawing the background, although would I really know if it wasn't? Yeah, I wouldn't know if it wasn't. I guess we could change the background to white temporarily. This should print 0, 0 equals 16. Oh, I didn't put this. Okay. Let's do that. Okay. So far, so good. Strange thing. So tile index is not equal to 0 because 16 is not equal to 0. I guess I already had this print statement here. If get tile property tile index -1 is player. No, get the player property from that tile. If it's true, set the player lock. Else, if it's not true, then set into entity tile grid XY, which is 0, 0, and then tile index -1, which is 16 -1, which is 15. Which is the corner. But why does it not get drawn? Okay, let's after we load everything, this is else if the tile index was 0, which it was not in our case, but if it was, then it would put the empty entity tile. But again, that was not the case for us. After the for loop, let's do print entity tile grid 0, 0 equals format y. Let me just get 0, 0. After it sets it, does it think it set it or not? It does. Maybe the display is messed up. Because it sets that in the entity tile grid to 15, which should be the corner. So let's do some more troubleshooting. Let's go open this. I'm gonna make the background white for now. Spreadsheet image. This actually comes from the JSON. File set 0 image. File sets 0 white. Okay, so this one still rendered correct. And this proves that the corner of our screen is not broken, because now the corner of our screen is white. If it was just simply not drawing those pixels or something, then they wouldn't be white. Huh. Well, that is very strange. So why is it not drawing the corner? What if we check on it out here? My game, entity, tile grid, 0, 0. Still says 15. And blank space is 17. It's not even like we're one tile away from the corner, and if we had accidentally like been off by one, then it would just, you know, be the black background. This corner is definitely filled in. Top left corner tile is not broken altogether because this one is the same tile and it renders correctly in here. Let's put ghost here. Why can't I put a ghost? Damn. Oh, it's not selected. We put ghosts in those spots. Save this. Export. This on. I think this fails because I saved this map on my PC. Actually, I don't know where that's saved. Okay. Oops. Yeah, so the ghost draws in the inner one, but not the outer one. So basically we're seeing the same behavior with the ghost. And we don't do anything else. We print, we append the group so it gets shown on the screen. We create this variable new lock, which we don't do anything with. We create this variable moved, which we don't do anything with. And then we just while true. Nothing else ever happens. And after we create the map, we already see 15. Well, now it's 12 because I changed it to ghost, but... Okay. We're gonna save this. We're gonna go back. And we are gonna start stripping stuff away to troubleshoot. Tile grid test. Okay. Tile grid test. This is gonna be basic tile grid code. Okay, I'm gonna do multiple. This, set up the display. Import this. This is going to take the whole tile map game helper out of the loop. Just using plain tile grids with nothing else. This is sprite sheet .bmp. This one is kind of like the player. 1 by 1, it's 15 by 15. Default tile. I'll leave it on 0. I don't know if it matters. Castle, that's fine. We'll put 6 by 5. 15, 15. Scale. I don't think we want to scale it. Default tile. This one doesn't have a default tile. I wonder if we should not be passing default tile on some of those. If we save this. So this should just be all jumbled, I think, because we didn't pay attention to which index was which tile. But might not crash. Yeah. So yeah, 0, 0 worked fine on this one. So let's make it the walls. Upper left corner we know is 15. Oh, right. Oh, and I can't redo it. We're gonna need to change that to CodePy. Okay, so that worked. We have the upper left corner. Let's do our make transparent on zero. That's the green. Palette. Palette. Make transparent 0. Should get rid of the green. Okay, I need to rename CodePy code Pacman. Rename tilegrid test code. Okay. So the top left corner worked. I'm at a bit of a loss. I don't know what could be causing that. The upper right corner, I guess let's fill in some more of these. The upper right corner is the next one, so 16. The lower left corner is 20, so 19. The lower right corner is one more, so 20. Top and bottom walls, so the top wall is, well, they're both the same. And it's 11, so 10. 10. Oh, this was already on 10. Maybe that's wrong. Left and right walls, this is 10, so no, we don't want a -1. We don't want a -1. Yeah, -1 we only care about when we're using the map. Because the JSON map tiles are 1-based. We don't want a -1. I don't want a -1. So lower left should be 20 and lower right should be 21. 20, 21. Now the top and bottom walls should be 11. Yeah. $11. Gonna save it. Oh well. Left and right walls. One less than 11, so 10. 10. Floor. We'll do the floor. We'll do the floor as the dots, the pellets. So number 4. Yeah, all of that's fine. So the tile grid themselves are not bugged. 0, 0 works fine. It's getting set to the top left corner, no problem. And I can change it to other stuff like castle 0, 0. 12, we'll change it to a ghost. And that works fine. So why is it blank? It's a 17. Yeah, that's basically what we're getting. $17. Okay. Let's go back here. Let's rename this tile grid test. Let's rename this back to code. And let's change it to something else. What happens if we change it? print here. It's not going to do anything matter for right now. Why is my print in this one not blue? Some of these don't have the right highlighting, and print is not blue. This could just be a problem in PyCharm, though. Some stuff is highlighted. I don't know, this could be not related at all to my problem, but I'm kind of suspicious of it. I also don't have a Python icon up here. It's not doing the square brackets either. Well, those ones it is. These ones it's not. It is in here. Huh. But again, this might not be related to my problem at all, but I'm very confused about why it's doing that. Kind of wondering if there's not one thing broken that's causing both of these symptoms. Thing not drawing correctly and PyCharm not knowing what? I put my cursor near this, it highlights this line. What on earth is going on here? No, really weird. Let's print hello though. Hmm. Settings editor file types. Now CodePy has a Python icon, which is nice. This is working. The colors are right now. The quotes still don't. Does not highlight a random line. Okay. That seems to be what was wrong with the editor, which is nice to get that fixed. This, however, is still seemingly broken. Okay, so let's just try changing some things on that tile. What happens if we go... What happens if we go time.sleep, 2 seconds. After 2 seconds, we say my game background tile grid 0 0 equals 12. That was our ghost. Yeah. What happens if we do that? Maybe we should put a print also, but surely 2 seconds has passed by now. Print changing background 0 0. Yeah, so we got that change and nothing happened. So that makes me think that the black tile, tile 17, is placed in the entity grid. Because the entity grid gets drawn on top of the background grid. So if it contained the black tile at 0 0, then it would cover whatever's in the background. So what if I now go my game entity tile grid 0 0? What if we put this to a blank one? 13. Can we then see our ghost? No. What? Do we have... Is the cursor tile grid? Maybe the cursor tile grid... We were covering it with something else. What if we don't change these, but instead my game dot entity tile grid dot x equals 15. Let's move it over by 1 tile. Down also. So shift the entire entity map. It's going to push the right and the bottom sides off. But it draws correctly. So the corner is there. The corner is there and it's covered up by something. What is it covered up by? My guess is the cursor. Even though we try to take the cursor out. What do we use 17 on? 17. Cursor default tile. Yeah. It's covered up by the cursor. Gotta be, right? Yeah. Yes. Yep. Right here. This is setting the cursor default tile to 17. It's 1 by 1. Its XY is not declared, so it ends up being default, which is 0 0. we never change the location of it because we're not trying to use it. This should not be true. So we should only do this if use cursor. Man, that's a bunch of time to waste on such a silly mistake, but that's how it goes sometimes. No attribute. What's the traceback? Line 92. Right, can't append it if it doesn't exist. So why don't we take this, put it here, put this inside. I also want to put this as well. I don't know if we could change the location right now. Or if we would need to call these first. We could do that. Just be restarting extra times. Not the end of the world. Okay. All right. We rendered everything. We have our corner. It's not being covered up. We can actually see it. So everything is good now. So let's work on moving the Pacman. So actually, I started a class here. Hey, Johnny, how's it going? Started a class called Entity. I think I want to use this class because it has some logic to like helper functions to grab certain pixels that are in the center of the side that we're facing currently. That way we could try to determine if we're allowed to walk onto the next tile or not. Yeah, it's probably technically some kind of infringement. I did draw all the assets myself, so at the very least, like, I didn't just steal Pacman assets, but it has an uncanny resemblance to a pre-existing game that may or may not have been called Pacman, possibly. Yeah, Pac Circuit. Or I was going to call it Pie Chart Chomper, I think. I like the idea of Pacman being a pie chart instead of a monster. I think I want to use this class for the player. I'm going to paste this over into lib. Yeah, PACK Pacman. I mean, if my player is a pie chart, that's clearly differently than their player, which is a circle with a mouth. It's definitely very different. So where would we would use entity when we initialize the player, which is this. So I think here we want to create one of those entity classes instead of just a tile grid. But before I do that, I actually got to run to the restroom, so I will be right back. I think this is the first investor meeting. I think. I don't know. We have no funding yet. I don't know. Maybe, I think, though, they might have more of a problem with it if we start collecting funding. I don't know. Maybe we'll have to hold off on funding. All right, I'll be right back. Okay. Bar chart. $5. Nice. What are the enemies? Yeah, I guess we should make something different for the enemies instead of pellets. They could be just dots, or they could be plot points. Like on a plotted graph thing. Quarterly reports are the enemy. I like that too. Nice. History, they actually had an article about Pacman in it. Turns out it was designed to attract women to arcade games. Interesting. I could see that. I know they had Mrs. Pacman pretty early on after the original one, so this kind of makes sense. Phillips made a non-clone and won in court. Interesting. Never knew there was a court case of it. I don't know who owns the Pacman IP at this point. I kind of assume that they're just not doing too much with it. It's been so long, right? I don't know. Do they still make new Pacman stuff? Namco. Do they still make new stuff? They went defunct in 2006. This company. Did somebody buy it? I mean, I'm sure somebody bought it, right? Bandai Games. Yeah, it looks like they're now operating inside of Bandai. I don't know. I'm hoping whoever actually owns the IP at this point is not going to be that strict about it. Otherwise, we might have to like reskin it or something, make it look different. Sorry. Pacman. Pacman owners caught in game IP maze. Oh yeah. When is this? Oh geez, this is only 3 years ago. Okay. So I guess they are still pretty sensitive about... Oh, you know what I don't have is the big dots. I don't have fruits yet either. They were provided a license by Bandai Namco. Well, if they were provided a license, what's the problem? Let's see. I don't have any company name or branding. I don't know about intellectual property. I redrew all the assets myself, and they're certainly not like pixel perfect, so... But I will not try to say there's no resembly. There's definitely a little bit of resembly. I don't know. There's no resolution yet either. It doesn't look like. Makes sense if it was 2019. These kinds of things take forever, it seems like. But I don't know. Hopefully we'll squeak through and not be a problem. But collecting bitcoins, it could be that. The target hardware. So right now I'm working on this. It's this Pico WaveShare LCD. This is what I built the library for last week. It is technically from, well, I got it from Amazon. WaveShare 0.14. It's this device right here, which plugs on top of a Raspberry Pi Pico. That's interesting. Got the little Explorer board thing. You could probably play it on the Pi Gamer. We would have to, we'd have to change up the camera size and some other things. One thing that would make it not ideal for the Pi Gamer, I will say, is that the tiles are 15 by 15. And the Pi Gamer screen, and I chose 15 because the resolution of this display is 240 by 135 right there, which divides evenly by 15. 15 pixel tiles divides evenly into that. The Pi Gamer, though, is like, I think it's like 128 by 164 or something like that. It's whatever it is, it divides by 16 instead of 15. So if you ported it to the Pi Gamer, you would either have certain tiles run off the edge of the display, or you would have like blank spots, like you could just not fill in those tiles, or those pixels, I should say, and it would just not use up the entirety of the screen. So it could work, but I will say it's probably best suited for screens that do have a number of pixels divisible by 15. Yeah, it wouldn't be that big of a difference. Wouldn't be that big of a deal. So you could draw it on there. Just have a little bit of blank space or something. Okay, so I think what I want to do is get the Pacman, well, get the pie chart, which is definitely not a Pacman, get the pie chart moving. So I think what we want to do is when we initialize this, instead of initializing the tile grid, we want to initialize this other class, which is called entity. Again, just has some helper functions and properties to select certain pixels to find out essentially to find out if we're allowed to walk in the direction we're facing is what it's for mostly. So self dot, I'm not going to call it sprite tile grid anymore. Call it player entity. We're going to have to change a bunch of stuff to you know, count for the fact that sprite tile grid doesn't exist. Entity. We're going to import this from here, but it doesn't need all of that stuff. I shouldn't have saved yet, oh well. And we need to fill in some parameters. There's let me put the music. Okay. Some of these things are the same. Bitmap and palette, those are the same. Width and height. Actually, all of these are the same. Copy this. Default tile, that's also the same. So it actually has the same signature as tile grid. Okay. Player entity. So I think I would also like these to be private and have properties, because this entity doesn't extend tile grid. Instead, it has a tile grid as a field. I think I had a reason for it, but I'm actually not 100% sure what it was at this point, because this was about a week ago that I wrote this. fx self return self dot. Actually, to be honest with you, I should just always take it from the tile grid. Yeah, I don't even think I should have X and Y variables, because then they could get out of sync with the tile grid. Not being used anywhere yet. Let's get rid of these. So if you ask for X, you get the tile grid's X. If you ask for Y, you get the tile grid's Y. If you try to set x.setter def x new x, you set the tile grid's Y, self.tilegrid.x equals new x. Same thing for Y. Y, and Y. Okay. Now we have getters and setters for X and Y. We should make a tile grid getter, I guess. Tile grid, turn the tile grid object. And then, yeah, so we're gonna need to change a bunch of this stuff. So for now, I'm just gonna comment this out. Eventually I'll need to like actually come through and clean this up some. We'll say self.player entity.tilegrid. Append that to the group. Unresolved. Yeah, I don't know, it is resolved, it just doesn't know how to find it. Update player location, this will need to be different. This is basically getting interesting. Okay. I think I want to just not call that for right now. I just want to not call that. What happened here? This got messed up. Right, all of this should be like this. What happened there? I guess it wants it more like that, I guess. So it can't find its own functions for some reason. I'm not really sure why. So when we're loading tiles, when we find the player, okay, this is putting maybe we do want to call this still. I think we do want to do this still. So when we find it in the map, we're setting it into the dictionary player lock. Some things will still change though, because this dictionary is assuming tile locations, like the player would be at, you know, like tile, you know, X1, Y2 or whatever. But our player, it's going to be different. It's going to be allowed to move by pixels. So we still care which tile it's on and which tile it's moving to, but it's allowed to be in between the tiles. So we'll leave this for now, though. We'll set the player lock. And then in update player lock, we'll say we'll change this. Self player entity .x, and it should just be able to equal the same stuff, because that's gonna set it into the underlying tile grid. Self.player entity y. Okay. So can this still draw the player? Doesn't look like it. no attribute. Looks like it says no attribute map object. $39. Should definitely have a map object. Map object. Something is messed up here. Yeah, these need to be indented. Why? How did my indentation get messed up? What else got messed up? So this is why it couldn't find those functions. I guess it got messed up when I did this. Go. Oh, nice. You did some math to figure out the number of tiles we could use on different devices. 160 by 128, that's what it is. 16 by 10. 10 by 8. Or it could be 10 by 10, and then you get 16 by 12 with 8 pixels left over. Interesting. Nice. Thanks for mapping those out. Okay, so hopefully this is fixed now. No. Unity object has no attribute tile grid. Line 95. Sure, we just added one, didn't we? Tile grid? Self.tile grid? It does. Isn't it? Property. ILEG. Ah, tile gird. Got the old tile gird. There we go. Oh, nice with PyPortal. Yeah, I've been thinking about PyPortal. I kind of want to make something that's a little bit like this this Etch-a-Sketch. I don't know. I have to zoom out, I guess. Be able to fit it all. But I have this Etch-a-Sketch which has a PyPortal embedded in it. I think it'd be cool to make a game system that's like this. Like put a D-pad and a couple buttons down here, and then keep the PyPortal screen mounted in the top like that. I think it'd be cool to make a kind of like a handheld game thing like that out of the PyPortal. Been kicking that idea around. See if we can fix the focus here real quick. There we go. And this looks like it worked. So we got the pie chart drawn in the right spot still, and everything else seems to be fine. So that's good. It doesn't really change anything from how it was a moment ago, but now we are using this entity class, which is going to be helpful when we start moving the player, which is the next thing I'm going to work on. So let's try to make it to where when you press right, the player will start moving to the right. So how do we do that? We need to look in WaveShare, simple test. No. Oh, did I not make a test of buttons? Thought I got the buttons working. Oh, I wonder if I overwrote that when we started. Yeah, I totally don't have that anymore. That is probably the thing we overwrote when we started. Does PyCharm have it? History? All the way back to the first time I touched it today. Now this was just simple test. Okay, this one has events. There's the first one where it changes. Okay, so I guess all I was doing, the only thing I had was get key events. And I guess the prints, do the prints come from inside the library right now? Yeah, they do. Okay. So we should not, we should do this differently. We should return event here. No new line. And then in our CodePy here, we can say get rid of pass, event equals lcd dot key event events. If event just print it for now. Print event. We'll run that. Let's get the camera back. Okay. If I push right, yeah, we got right pressed and right released from inside the library. That's right here. But we also got it printed from our CodePy here, the event object. But I think we don't want this to print inside of the library. Instead, we can put this logic out here. If event.pressed, honestly, we could just copy this, right? This. Paste it. Into uncommented. The one difference is keydict is not in self, it's in LCD. LCD. So now we should get a single print, and it's coming from CodePy, not the library. No. Broke the indentions. About like that. Yeah. Okay. Press right and released right. Okay. And do the other directions? Down, left, up. Okay, all those work. So now what we want to do is when the user presses right, we're going to tell the entity that it should be facing to the right and that it should be moving. We have directions. Direction, currently none. So let's see. How do we want to do that? Let's say if we... Is it key.number or event.number? Print event.key number. Okay. So if it was pressed, if event.key number is lcd. Right, then player entity, so my game dot player entity, we should make it not private. I think it's like this. I should go back and change it to not be private, or maybe we could have a public accessor that is like underscore. Make a public accessor. Extra spaces on all of these. So let's say property def player. Yeah, I could just call it player, I guess. Return self dot player entity. Close some of these. Okay, my game dot player entity. We can take this off now. Dot direction. Direction equals right. Equals direction right. Entity dot direction right. I already import this? No, we import it inside of the game helper. From entity import entity. Okay. Set the direction to the right. So we could press it, but nothing will happen. But the direction should have been set. So now our direction knows that it's supposed to be going right. So the next thing we need is, I guess we could put this inside of code as well, I think. After we deal with the buttons, let's say if my game player entity dot direction is not, if it's not direction none, then we know we need to move. Whoops. If it's any direction except for none, then we want to move the player in that direction. So let's see. This is where our helpers come in. Okay. So what we want to do is basically check the tile that we're about to move to, find out if we're allowed to walk on it or not. I almost want to... I almost want to change these a little bit. I think... I think that these should have X and Y added to them. Self.x plus, and I think I want to just go ahead and not get the pixel that's within the player entity, but I actually want to get one pixel outside of it, centered on the side that we're moving. So I don't want width -1, I actually just want width, because that's going to put me one pixel outside of the entity. And in this case, halfway down, all the way to the right, one pixel outside. So this would be self.y plus. And so adding self.x and self.y, this is going to make it in screen pixel coordinates. We want the same thing here. Self.x plus self.y plus. We want this on all of these. Copy this. Could have got a space also. I think I have a space. Guess I only have one left. No, I just didn't do this one. And okay, we also need to do same thing we did here. Basically, we got rid of the -1 so that we would go one pixel outside. So on top, we would say not +0, but actually -1. We'll need to check for negatives later, but I'll deal with that when we get to it. So right, we already did. Left would be -1 here. Bottom, take out the -1 here. Okay. So now we have these properties that will let us access the coordinates of essentially the next pixel that we're about to move on to. So let's also do property def, no, property def, I don't know, maybe we'll rename this later. Next pixel current direction, or in direction? No, current direction. Current direction. I don't know. I might choose a better name later if I can think of one. So basically, this is just going to call one of these based on the direction that we are currently facing. If self.direction is direction up, then return top front, self.top front pixel. Just do this for each one. Probably a better way to do this, I don't know, maybe a dictionary instead of ifs, but so we'll set these down. Bottom, front, left, left front, whoops, left, I spelled that one wrong. Factor that. Go, right. Okay, right. Okay, so this will find the current direction, get us the pixel that we are interested in, basically the pixel that we're about to move to. So if we're moving, then get that pixel. Next pixel lock is my game dot player entity dot next pixel current direction. Print it. Let's just print it. Let's not do anything else yet. Let's just print it. So this will spam once we set the direction to right, but that's okay. So when it first loads, nothing's happening. I'm going to push right, and it will start spamming over and over the next pixel. Essentially the one pixel outside to the right of Pacman in the center of the pie charts sprite, which I will try not to call Pacman. So we would want to check that pixel, find out what tile it belongs to, and then find out if we're allowed to walk on that tile. So we say, let's look in the game helper. We have like can walk. The tile is tile movable, tile chords, but we need to get the tile chords from the pixel chords. We don't have a function for it yet. I guess we just divide, right? Yeah, we just divide. So if my game, these would fill in for me. Is tile movable? This should have a different name as well. It implies that we would move the tile, which is not actually what it is. It should be like, is tile walkable, or can walk on tile, maybe? Something like that. Coordinates are going to be, it's a tuple, I think, and it's next pixel lock x, which is 0, divided by tile width. My game tile width. We should put this down. Bring this back. Comma. We shouldn't have put that down. Next pixel lock y. No, 0, 1. Divided by my game tile height. These should not be private. We'll go back and change that eventually. Okay, that's our tuple. This is like this. Okay, if, okay. Print, let's just print again. Can walk on next tile. So now it should spam that instead of the coordinates. But it's not. I could take out this also. Got all of this. We figured all of that out. Don't need any of this. Next pixel lock. Okay, next tile chords. This. Print next tile chords. I never pushed the button. This should be here. It's also, now it's going to spam two things. We don't really need that. Let's turn this one off. Indices must be integers, not string. Oh. Looks like this one's a dictionary with XY. Yeah. Not a tuple. Okay. So that's easy enough, right? Just dictionary X. X is that. Y is this. Okay, come on. This. No, Y, come on. Here we go. Okay. Put spaces, I guess. Dictionary now. Okay. Push right. Okay. So we are allowed to walk. Index, I don't know, that's getting printed inside here, I guess. Yeah. Just turn that off for now. So it looks like it's working. It's spamming over and over that we are allowed to walk on the next tile, which makes sense because the next tile over from where PyChart is currently, we are allowed to walk on because it's not a wall. So if we are allowed to walk, let's take one step forward. Let's move by 1 pixel in that direction. So then let's say we are allowed to walk, so let's go my game player entity dot. We actually need to know the direction, don't we? If my game dot player entity dot direction is entity dot direction right. We'll just hard code right for now. We'll come back and add the others later. If the current direction is right, then set the x up by 1, right? Just plus equals 1. So this should move by 1 pixel over and over until it finds a tile that we're not allowed to walk on, which would be all the way over here on this wall. And then it should stop because we're not allowed to walk. So this would start returning false. We would not go in here and update. And all of these are related to self.x. So those are going to be getting constantly updated when we change the x here. Okay, I think this should work. Let's run it. Save this. Okay, moment of truth. We're going to push right. I have no idea how fast it's going to go either. Pretty fast, but it did work. So 2 things to note. I think we want to slow it down some because it would be impossible to play at that speed. And also our tile that's in the spot where the player was at is wrong. I think that's because of our default tiles. I guess we should make the default tile of entities be 4? Or do we need to go up to 5? We'll find out. Entity tile default? Name of it. I don't know why these aren't filling in for me. It doesn't know how to find it from inside a lib. I'm gonna try to figure that out. Entity. No, entity default. Default. And equals. What did we say? 4. So do we get a dot now under where the player was? Yeah, okay. Okay, we're getting pretty close at this point to having, like, I mean, obviously the game, there's still lots to do to make the game, but the framework of, like, all of the helper stuff is almost ready, and at that point the game is going to be pretty easy to code, I think. So let me do a few things. Let me try to slow down the Pacman. Also, let me say if we are not allowed to move to this tile, so else my game player entity dot direction equals entity dot direction none. So no longer have a direction. That's not going to make any difference for now, but we should have it because eventually we're going to want it. Let's also try to make the Pacman sprite, the pie chart sprite. Let's try to make it get filled in and unfilled in, right? Because we have these different pie charts. You know, this one has this section over here cut out on the right, and then this one is basically the same sprite, but it has that section filled in. So if it were a monster, which it's not, it would look like its mouth was opening and closing. We know that's not the case because, of course, it's a pie chart. So obviously just the data represented by our chart is changing. But we want to represent that with the sprite in the game. And we also want to slow it down some. So let's do a... let's do... What do we want to call this? Update or tick speed? How fast the game tick will happen? I'm going to set this to 300 milliseconds. Import time. I think we don't need board. Previous tick 0. So we want to get the key events as fast as we can, I think, but we only want to move, we want to slow down the movement. So if previous tick plus tick speed is greater than time.monotonic which is in seconds, I think. We want milliseconds. We want less than. Do we want less than previous tick plus the tick speed? Yeah, we want less than. So basically we want this amount of time has passed since this time, and we are now currently later than that. We've gone past that point. The first thing is this, I should make a now. 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 Should be now. This way we don't call time.monotonic multiple times, because then it could be one value when we check it in the if statement, and then a different value when we set it down here, and a different value when we do something else with it. We want it to be consistent for the entire tick. Even though technically the tick is going to take some amount of time, so like time is still passing obviously, but we don't really care about that much of a difference, so we want to keep it consistent. So set the previous tick to now, and then do all of this stuff. So this should slow the player down to moving 3 times a second. And if that's still too fast, then we'll slow it down further. Okay, it's not working. My logic is wrong. Okay, so print now. Okay. Yeah. I should have done times? Done times, I think. Can I get these to print without this? Can I get these to print just the int, even though it's going to be long? Python. Actually, you know what? Why don't I just change the units? Let's just say monotonic is in seconds. So let's say this is actually 0.3 seconds. And then let's not worry about this. Now equals current time. Previous tick is going to get set to now. Tick speed is 0.3, so 1/3 of a second. Okay, that looks good. So right arrow? What's this? Okay. That is working, but that's way too slow. Way too slow. But it is working. So we can just change the tick speed now. 1/10 of a second? Oops. Okay. Right arrow. I'm gonna wrap it up pretty soon. I'm pretty happy with the progress I've made. We got the map drawing. We got the player moving. It's still probably too slow. Pacman would be a lot less fun if you played it at this speed. So let's get rid of this, so we're not spamming the console. Let's speed this up again. Maybe, what if we put like 1 second divided by 30 updates? What if we say 30 updates per second? I don't know if the screen can even keep up that fast. Let's see what it does. Okay, that's not bad. It's getting closer. It's still pretty slow though, honestly, compared to like playing the game, which is sort of similar to this called Pacman, which we are definitely not making. Let's save this. Try 60. There we go. That's pretty good. That's pretty good. Okay. I think what I would like now is while the pie chart is moving, I want to continually switch the sprite with the one that has the pie chart completely filled in, so that if it were a monster, it would look like its mouth was closing. But it's not. It's a pie chart. So do we want to do this at the tick speed? That seems awfully fast. That seems awfully fast. Player, sprite, change, speed. Previous player, sprite, change, 0. So this is going to work the same way. Let's say we change this one, though. Let's do this one 3 times per second. Three times per second. This is basically movement ticks. We could have just a different if statement. That in the right spot? Yeah. If previous player sprite change time plus speed less than now, mygame.playerEntity.tileGrid 0, 0 equals so actually we want if mygame.playerEntity.tileGrid retrieve 0, 0 if it's currently. I'm just going to hard code these. Eventually we're going to have to figure out how to keep track of which ones we want based on which direction we're moving, but for now I'm just going to hard code right. So if it was currently 0, we're going to change it to 5, and if it was currently 5, then we're going to change it to 0. So if it's equal to 0, change it to 5. Else if it was equal to 5, then change it to 0. So it'll just go back and forth. Okay. And most important part, set this to now. Okay. Oh. Okay, so that is working. Our pie chart is now getting filled up and unfilled. I think I would like that to only happen if we're moving, though. I think we should say if mygame player entity direction is not entity.direction none. So only do that if we're moving. Whoops. That's cool though. It does look like it's gonna work. Okay, there we go. So now we keep the same sprite if we're not moving. But if we are moving, then we get the chomping. Perfect. Okay. I think that is going to do it for the stream today. Definitely made a lot of progress. We got the map created. We got the map rendering. In order to do that, we had to change a bunch of stuff inside the map helper to non-hard code sizes of a bunch of things. The old map helper library was all hard-coded. In fact, I should take this, grab all the code out of it, and I'm going to update it in this repo. And we still have work to do. Like, we just commented out the old sprite entity tile, or the sprite tile grid, and we kind of replaced it with a new thing. Eventually, we probably want to go back and clean that up and also support the old way we were doing it, where the player basically snaps to the grid. That's how it used to work. The player would always be snapped to a grid tile. We probably want to offer a Boolean or something like that that lets the user decide whether their player is going to be stuck in the grid or their player is more like this one, just allowed to go anywhere they want. Every single pixel is fair game. Again, as long as they can walk on it, right? We still check the property to make sure that can walk is true. Of course, we need to actually chomp the little dots there, so we'll make it so that when our pie chart moves onto a tile, if there's a dot on that tile, then it will take that dot away and maybe add to the score or something like that. That's all still work to do. But we got a lot done today, and it's definitely starting to look like what we're aiming for at this point. So I'm pretty happy with it, with the progress we made today. I don't know for sure. I may finish this before next week's stream, or I don't know about finish. I may work on this before next week's stream. I'm not sure. If I haven't done it by then, though, then I'll plan on doing this during next week's stream. And if I do get inspired to work on it before then, I might pop the stream on like Twitch only, or we could probably do both, I guess. But I'll drop maybe drop a note, but I don't really know when that will be, so I can't tell you, for sure, like it'll be this night or this day or what time or anything like that. But if you're interested in seeing the next one in the series, if you're watching this game get made, you could hit me up on Discord and let me know that you're interested, and I can ping you if and when I start working on it. But other than that, that's going to do it. Thank you all the folks who tuned in and helped out. David, thanks for making that chart there that contains all the different sizes we could use. I do appreciate that. Johnny, Dexter, did we miss anybody? Oats and Honey. Yeah, thanks to all of you folks for tuning in. And I'll be back next week at the normal time, which is 10 a.m. Central Time on Saturdays. That's what time I started streaming today, and that's what time I normally stream every week, so you can catch me at that time, again, 10 a.m. Saturdays. And so, yeah, I hope everybody has a good weekend, good day, everything else, and I will catch you next time.